Hello, my name is Paweł Biernacki. I would like to show you some stuff I have found during the last 25 years, beginning from my studies concerning the artificial intelligence. So this is a very popular topic at the moment. You can check it at almost millions of data are available about artificial intelligence, and every day something new comes, and I wanted to share with you what I have achieved in it. And let's start. So you can take a look at my website perkun.org. It's www.perkun.org, where I have a menu about Perkun, Svarog, and Wroclaw. These are names of ancient Slavic gods, by the way. And so in another video I have shown you how Perkun works. It is a command line interpreter. And now I would like to concentrate on Svarog, which is the next step. It is somewhat stronger than Perkun. It is not a general purpose programming language. It is a very specific purpose programming language, and I will show you how it works and what we can do with it. You are free, because it's open source. You are free to download it from this GitHub repository. Compile it. It's written in C++, quite ancient C++. It's 98, I think. And when you clone the code, you have to compile it, and then you can run it. I'll show you how. So you run it like Svarog, and you have to put a file name, and this is how it executes. This specification written in the Svarog language. The Svarog language has been described a little in and actually the whole algorithm that is used as a basis of Svarog and Perkun is described in this document, Wroclaw 000 PDF. So it is the first version of the document, but it concerns the optimization problem. You might have noticed that I don't use neural networks. This is something that many people do. So many people do use them. I don't have any neural networks. I might use them in the future, but it's not the case now. It's just a pure mathematical algorithm, and its purpose is optimization in a problem when we have environment, a single agent. First of all, as you see in this paper, single agent with environment that is stochastic, with uncertainty, and with discrete time. And you don't have any opponents in this problem that I'm trying to solve. You just have one agent that is planning one step after another step after another step. So some n steps in the future of possible actions, which of course leads to a game tree. And we have no other agent involved, and we see something about the environment state, but not everything. That's why we have uncertainty here. And it is not like in chess, for example, where all the consequences of your actions are deterministic. Instead, in our problem, we have stochastic element. So whenever you do something, you're not sure what outcome it will, in general case, it will perform, what outcome it will produce. Okay, so you could run it from command line like I showed with Perkun with some specification, but I suggest you to download another program, which is Dorban. It is also accessible from the Perkun.org website, and on SourceForge, not on GitHub, is this program Dorban, and this is just a demonstration for the Svarog library. It's an overlay or on top of it. So in general, when you run Svarog this way in a command line and you have some specification in Svarog language, you're supposed to type the input values, the input variables values, and this may be a little cumbersome, so it's better to use Dorban. And that's how you do it. You just type, after of course downloading it from here and compiling it, you just type Dorban and it opens a window. So I will now switch to this window, this other window, and I will show you how it works. Okay, so I'm back, and you can see the Dorban when you with some, which is a GTK application. So it has a window, and you can in the menu start a new game. There's no saving or opening existing game. You can just create a new one. And the situation we will be talking about here is a Dorban, who is a witcher. There's a space of 5 towns, 5 Polish towns: Warszawa, Gdansk, Krakow, Wroclaw, and Poznan. As you can see, maybe it's not very visible, but if you run the Dorban program, you'll be able to see it yourself. And there's a vampire. There's this currently he's in Gdansk. Every time you run the game, he may be in different location, in one of the 5 locations. But Dorban knows for sure that that the vampire must be somewhere. And apart from that, there's Pregor, this character that is in Krakow currently, and I can control him. So I have some actions that I can perform, like go to Warszawa, go to Krakow, go to Gdansk. So maybe I'll go to Wroclaw. You see, now Dorban went to Warszawa, and in this time the vampire did not move at all, and me, the Pregor, moved to Wroclaw. Dorban knows that there's a vampire here, and he also knows that the Pregor is there, and Pregor is supposed to help him to beat the vampire. He can't kill him, but he expects to beat him, and he likes winning any encounters with the battles with the vampire. But he knows also that that Pregor can't help him if he's dead, and Pregor can be dead. This may happen, for example, due to a vampire attack, or Pregor can die because it's accessible here as a miracle, resurrect and die. And concerning the resurrection, he knows nothing about it. I mean, Dorban. But I will show you how it works. Let's later move into details. I'll do nothing. I'll just wait. Still do nothing. As you see, Dorban moved to Krakow. Do nothing. Now he found me. He found me in Wroclaw. When I say do nothing, amazingly, he does not ask me for help. Normally he would ask me for help, but I should have told you that this specification, Svarog specification that is beneath the Dorban in this case, has a limitation of up to 4 steps in the future. So if I am in Wroclaw and I know that vampire must be in Gdansk, just moving to the vampire requires 1, 2, 3 steps, and attacking it is the 4th step. And this is all I can think about. I don't think that asking Pregor for help and then going the 3 steps to Gdansk and attacking vampire is it's not in my horizon of what I expect. My game tree is not deep enough to see the consequences. That's why Dorban moved just to Krakow, and when I do nothing, he moves to Warsaw, Warszawa. I still do nothing. He goes to Gdansk. I do nothing. The vampire has been attacked, and he failed. And this is one game that I wanted to show you how it works with the Dorban. When you run Dorban, please take a look at the command line window where you started it. You will see this is a belief in every step, every situation of the game. The Dorban has some states that he believes in. For example, he knows I'm alive, Pregor is alive. He knows that Pregor is in Wroclaw, as you have heard it. And he knows where is the vampire. He is in Gdansk. And this is 100% sure, so that's why we have 1 here. But normally, if we start, for example, I will teleport the vampire somewhere. It goes randomly to Poznan. And I do nothing again. You can see that now the belief contains many situations possible, because I have chosen to discard all the knowledge. That's how I handle the surprise, because Dorban does not think that vampire can move on his own, even though obviously he can. And now he thinks that if vampire has just disappeared, then he can be anywhere but in Gdansk. So you see the first place he considers is Warszawa, then Krakow, then Wroclaw, here, then Poznan. Anywhere but not in Gdansk. And what about me? I can be in Warszawa, Krakow, Wrocław, Poznan. I'm not in Gdansk because he didn't see me, and he doesn't know whether I'm alive or not. It may happen that because he discarded all his knowledge that he gathered so far, he just assumes that I can be as well dead as well as alive. And let's see what happens later. He goes to Krakow. He goes to Wrocław. And now he asks. You can see the belief as it is now. He knows already the vampire is in Poznan and I am in Wrocław. And he knows I'm alive. Pregor is alive. So now he asks me, would you please follow me? Would you please follow me? And I say, for example, no. I say no. And now I do nothing. Again, will you please follow me? So the decision is ask Pregor to follow Dorban. He will constantly, I would say it's a kind of insect-like intelligence. He doesn't learn from the past that the world does not obey what he wants, doesn't give him what he wants, and he will constantly just ask me for help until I say yes. And now you see a small symbol, Pregor following Dorban, on the right side of the graph. And let's just follow his orders. So now I choose a different option, follow orders. Go to Poznan. Why? Because he knows that the vampire must be in Poznan. And now I choose to follow his orders again. And Dorban orders attack vampire. Okay, we attack him. And sometimes we may win, sometimes we may lose. The point is that Dorban knows that he has better chances to win against vampire when I'm helping him. And it knows it from the specification. And he likes to win with the vampire. Now let's click on Krakow. He doesn't know that, but I can do nothing. So Dorban is now in Poznan, and he doesn't know where I am. He thinks I can be in Krakow, Wroclaw, or Gdansk. When I do nothing still, he'll go to Wroclaw, and after that he will come back. He will not go to Krakow. So he knows that I can be either in Krakow or in Gdansk, but I can't be, he doesn't know whether I'm alive or not because of this surprise effect. So I can be dead or alive. He doesn't know. It's 25% probability for all these cases. There are just four cases. So you have equal probability, you might say, always. At least in this type of game. And Dorban has just come back to Poznan, and now the vampire is being attacked. Failure. He attacks vampire on his own. Sometimes with success, sometimes without success, and he will keep attacking him like that. So now let's make another experiment. Let's jump to Warszawa. As you can see, he attacks. And let's jump to Poznan. And wait, do nothing. Now, he says, he knows, first of all, he was surprised. And in his belief, he has only one case. He knows for sure that I am alive. He knows for sure that I am in Poznan. And he knows for sure that the vampire is in Poznan as well. And he asks me to follow him. So let's say yes. Okay, now Pregor is following him. And follow orders. Attack vampire is his order. Pregor says I follow my master, as you can see here. When I do anything like moving to another city, like Warszawa, he will be surprised first of all. But when I do nothing, he will find me. Because he doesn't know again where I am. He assumes I can be in Warszawa as well as in Poznan, as in Krakow, as in Gdansk. And he just happens to choose Warszawa first as first destination goal. And he will ask me to follow him. Do nothing. Follow. Now I'm following him. and he will ask me to go back to the vampire, to where a vampire is. So follow orders, go to Poznan, because he knows the vampire is in Poznan. That's how it works. And I have some miracles I can use to test the behavior of Dorban. So for example, I can die. This is amazing that in many religions you have miraculous resurrections, but you don't have miraculous death. It's quite one-sided stuff. So anyway, when you say die, he will attack the vampire on his own. And I can't attack vampire, for example, when I'm dead. So I can only do nothing. You can see I tried to draw here little wings, like angel wings, on the Pregor figure, so that we know that he's dead. And Dorban will keep, when I keep doing nothing, Dorban will attack the vampire on his own. And when we look at what he believes in, he believes that we are both in Poznan, both the vampire and myself and Pregor, but I am not alive, and this is for 100%. That's why he attacks him on his own. Now I resurrect, and Dorban, in his model of the world, he doesn't take into account this possibility of resurrection. He just thinks it's impossible. So that's why he will be surprised. But he will ask me immediately to follow him and to help him. And obviously his next order will be to attack the vampire. And I say I follow my master. So just following orders. Okay. And now I wanted to show you a little more about the internals of Svarog. So what is below Dorban? And in order to do that, we will just operate on the command line interface. It will be less interesting that this one, but you will have some insight, I hope. So when you leave it, when you leave Dorban, it asks, "Are you sure?" Press OK. We left it. In the Dorban package, I have version Dorban 003. We have to go to the catalog Svarog. And this is almost the same specification that we use in Dorban, but it doesn't contain the so-called pre-calculated knowledge. So we will forget for now about the pre-calculated knowledge, and we'll just see the input variables. There are 6 of them. So has Dorban won a fight? False, true, none. So usually he gets the input none as on this variable, and when he wins, when he fights, it has to be either false or true, and that's why he always initiates the fight with vampire and expects to have positive outcome of it. So he expects to win the fight. Now another input variable is where is Dorban, one of the 5 places that we had in the graph. Then can Dorban see Pregor, false or true? Can Dorban see Pregor is alive? We have, when we don't see him, then we get the value none. This one, none. But if we see Pregor, then the output will be either false or true, depending on whether he's alive or not. So sometimes we just don't know whether he's alive, and sometimes we know for sure, either dead or alive. Then, can Dorban see vampire? Also false or true? And is Pregor following Dorban? We always know whether he's following us, whether I'm following him. In fact, it is either false or true, and it is marked by these gray two figures next to the graph in Dorban program. Okay, let's see what follows. There are 3 hidden variables. One hidden variable is where is vampire? One of the 5 places. Another hidden variable is where is Pregor? Also one of the 5 places. Warszawa, Krakow, Wroclaw, Gdansk, Poznan. And the information whether Pregor is alive is also a hidden variable. So occasionally we can see the value. So when we see Pregor, we know for sure is he alive or not, because we see it. But normally we have to treat it as a hidden variable, because we don't always see Pregor. It is an input variable whether we see him or not. And there is an output variable, which is one of the actions. There's 7 actions, I think. So ask Pregor to follow Dorban. So we ask Pregor to follow us. We can attack the vampire. We can go to Warszawa, Krakow, Wrocław, Gdansk, and Poznan. So one of the 5 places. Yes, so in this specification, in the section variables, we have all the variables, all the input and hidden and output variables. We could have more than one output variable, and then there is simply a Cartesian product. We control two variables on our output, but in this game we control only one, and Svarog supports many of them, of course. So now we can see another section, which is knowledge. And in this section, it is written in special Svarog language, which is somewhat more powerful than Perkun, and it is exactly the same idea as the Perkun's model. So it just tells the Dorban how the world works. In this situation, we have an action: ask Pregor to follow Dorban. We have 85%, as you can see, probability that Dorban will agree to this request, and 15% that he will disagree. So these are just numbers that Dorban believes. He expects to have better chances for Pregor to follow him, to agree to follow him, than not to agree. And of course, it's illegal to ask him if you don't see Pregor. So the information about illegality of an action is here in this language. Just this keyword, illegal. Illegal. Now, another situation. Dorban can see Pregor, but he's dead. In this case, it is also illegal. So we can't ask Pregor for help if we can see him, but we know that he's dead. It is also illegal in this case. And we don't ask him to follow us. It's illegal when he's already following us. In that case, we just skip this action. Okay, another action is to attack vampire. So of course we must see vampire to be able to attack him. So it's illegal to attack vampire when no vampire is visible to us, to Dorban. Then there's 80% probability of winning fight. That's what Dorban believes in. In fact, it's 0. So well, you can win, but you can't kill the vampire. I would say like that. So it's really 80% of win, but you can't hurt him. And with Pregor, the chances are 80, 15 failure, and 5% that that the Pregor dies in the attack. That's what Dorban believes. Again, so he risks in a way Pregor's life. And if he attacks the vampire on his own, the chances are 51%, as you can see here, 49, and of course Pregor can't die because he's not helping at all. The other actions are just go to some place. So go to Warszawa. If we are in Warszawa already, then it's illegal. If we are in Krakow, then it's legal. And with probability 100%, we end up in Warszawa, because there is a connection between Warszawa and Krakow. Again, from Krakow to Warszawa, 100%. So it's never like that we intend to go to Warszawa from Krakow and we fail. It's always 100% certainty that we end up there. It's just in this game. In some other game, we could have it like in this stochastic fight case, so that there are 80% chances of achieving Warszawa, but 20% that we don't achieve it, that we end up in some other town, city. Okay, from Warszawa to Wroclaw. This is interesting because it's illegal, as you can see. This illegal is caused by the fact that there is no connection from Warszawa to Wroclaw. The Pregor can move to any city he wants without observing the structure of the graph, but Dorban doesn't. He's not able to do that, and he always must obey the graph, and so from Warszawa to Wrocław it will not come to his mind even to try it. Then from Warszawa to Gdansk it's possible, again 100%. From Gdansk to Warszawa also possible. Warszawa to go to Warszawa from Poznan, yes. From Poznan to Warszawa also. Now we consider the action go to Krakow. If we are in Krakow already, then it is illegal, obviously. And to go to Krakow from Warszawa, it's legal. From Warszawa to Krakow, it's also legal. And that's to Krakow from Wrocław. It's also legal, also 100% certainty of success. To Krakow from Gdansk. Interestingly, there is no connection directly from Krakow to Gdansk. We have to go to Warszawa first, and that's why this action in this case is illegal, as you can see. The same Krakow and Poznan. These two cities are not connected, and that's why this action is illegal. Later I will maybe show you how I produce this, because I didn't write manually this specification. I just produced it with some script, a script written in Perl. So I just defined which cities are connected, and the rules for the model, the knowledge about the world for Dorban is implied by these tiny facts describing connections between the cities. Okay, now go to Gdansk. In some cases it's illegal, so for example we can't go to Gdansk from Krakow, we can't go to Gdansk from Wrocław, we can't go to Gdansk from Poznan as well. And go to Poznan. Sometimes legal, sometimes illegal. Yeah, like from Gdansk, for example, it's illegal. Now, we have also in the knowledge section, we have in this language, in this specification, we have informations that some situations may not happen. It is done by the structure impossible, and there is a comment following it. So, for example, Dorban cannot see Pregor. It's impossible that Dorban cannot see Pregor, but he can see whether he's dead or alive. So it requires us to have only none, and we can't see, if we don't see Pregor, we can't have true or false as value of this variable. Can Dorban see Pregor is alive? Pregor is alive. Another situation which is impossible. Pregor is alive and Dorban can see he's dead. So this is contradictory. When some hidden variable, Pregor is alive, is true, but we see that he's dead. It's impossible also. And so this is pretty much the same idea as we had in Perkun, but it's it has a little more, it's a little richer syntax and achieves a little more expressive language. This objective. Now the definition of a payoff, as you can see here, payoff for winning a fight is 100 points. It says that initial value of this variable must be true. Losing a fight is minus 100, minus 100. Here it is. So it's false. And the neutral payoff is 0. So when we just get the input none, then this is usually the case. We are not happy, but we are not unhappy either. We just get 0, but we like 100. Payoff is controlling the objective of the agent, and you have to always keep in mind that you must never use the hidden variables here. Payoff is always defined for input variables. So we always know whether we won a fight or whether we lost it or whether we have none as a result, which is we did not fight at all, so we have none. And we can't, for example, have payoff depending on where is vampire or where is Pregor, because these are hidden variables. And we can't, in the design of my algorithm, I didn't want him to believe something that he likes to believe. That's why I just don't allow that to be dependent on the hidden variables. And now you may ask why it's so damn fast. Because the algorithm that I have been describing is quite complex, and it has been calculated up to 4 steps in the future. As we have seen in the first situation I showed you, there were just too many steps, more than required than 4, and that's why Dorban did not see any possible success in his planning, and that's why he turned towards Gdansk directly. And we need pre-calculated knowledge to make this work so quickly. Pre-calculated knowledge is actually something optional, so you may not have it in your specification, and it's perfectly okay. But then each step in this game will take like an hour or 2 hours, and now it takes hundreds of milliseconds, a fraction of a second, maybe a second sometimes. So I will tell you later how we make this pre-calculated knowledge. Important information is just that here is a number that says that we pre-calculated it for 4 steps in the future, and the granularity, which is how precisely we granulate. I don't know how to say it in English. The precision, how we divide the possible states, is 2. It must be 2 or greater integer number, so the minimum was 2, and normally we will calculate it for this visible state. A visible state is a combination of all input values with all possible of input variables with all possible values. And for example, here we have when after we failed in a fight, we are in so Dorban is in Warszawa. He can't see Pregor. He doesn't know whether Pregor is alive, and he cannot see Vampire, and obviously Pregor is not following him. Then there are so many possibilities, about 4 billion, as you can see here, that it's too complex to calculate the optimal action for all of them. And then we go just a different direction. But this is just an optimization of this algorithm. I think I will show you later how it is. So here are optimal actions on beliefs. Depending on belief, when there are 32 possible states, it implies that there are 32 dimensions in the space of belief. And we just for the canonic base of if you know what canonic base is from algebra, canonical base, you can calculate the vectors. For example, let's choose the vector Vampire is in Krakow, Pregor is in Krakow, and Pregor is not alive. If we are sure of that, then another option, Krakow, and he's alive, true. In the first situation, we just go to Krakow and we expect 6 as a win. It's an expected value of the payoff. And if he is alive, we expect 99, almost 100. So we know that in the very next step, we will ask him for help if we go to Krakow. And we will then attack the vampire together with Pregor. So you see that in this pre-calculated knowledge we have first a visible state, so what we can see, and then depending on what we believe in, we have internally different belief vectors, if you like, and as a result we have expected value. This is expected value here of the payoff function, and the optimal first action. And this pre-calculated knowledge is something that tells the agent what he should do, depending on what he believes in and what he can see, but not why. He has no justification for it, and this is quite interesting. So it's just been calculated like that, and we know this is good. It's a good situation. This one is bad because we will probably be needing to attack the vampire on our own, but it's still good. Now, this is when Pregor is alive is false. We just go to Krakow. This situation is good, obviously, and so on. And you must know that all this that I have shown you, all these pre-calculated knowledge strategies have not been produced by a man. They have not been typed manually. Instead, there is a special procedure described also in this document Triglav 000, which says how to achieve this pre-calculated knowledge. And you just have to set the computer, for example, for a couple of days calculating, and it will produce a pre-calculated knowledge included into the specification, and then we will be able to work with Dorban much faster, much faster, in milliseconds, as I told you. Now I'm looking for visible state. I found it here because this is an interesting case. You may remember that in one visible state where it was really no hope for us, we had 32 dimensions, 32 possible states, and it makes so much possible beliefs that it really makes no sense to calculate them all. But if we have only 8 states, then the amount of possible beliefs with the granularity 2 is 255, not 256, because there's one belief when we achieve 000 for all facts that can't be normalized. It can't be normalized. So that's why we have one less than 256, exactly 255. And for each of the 255 beliefs, we have the belief not only for a vector in a canonical base, but for all cases. Yeah, you can see it here. We don't have only one case, but 2 of them. 50% for this and 50% for this. So let's investigate what it says. When the vampire is in Warszawa and Pregor is in Krakow, and we don't know whether Pregor is alive because he has 50% probability to be dead, as well as 50% probability of being alive. Then the optimal action is to go to Krakow, and this is the expected value of the payoff function. So we choose to go to Krakow. Then we will see whether Pregor is alive or not on our own. And then if he is alive, we may be able to ask him to follow us. And he may say yes, there's a chance. And then we will go back to Warszawa, and then we will attack together with him the vampire. Maybe I will find another. Yeah, here there are 3 possibilities in this belief. Namely, either Pregor is in Krakow and we don't know whether he's alive, 33% for dead, 33% for alive, or he's in Wroclaw and we know for sure that he's dead, 33%. Then the optimal action is to go to Krakow. Even though we know that the vampire is in Warszawa. Why? Because there is a chance that Pregor is alive. This one here, this case. So when we have a chance that he is alive, but only if he's in Krakow, then we have to give it a try. We have to go to Krakow, ask him to help us if he's alive, come back to Warszawa, and then attack the vampire together. while if he's in Wroclaw, it will be of no use to go to Wroclaw anyway, because if he's in Wroclaw, then he's dead. That's what we believe. So as you can see, we may in this pre-calculated knowledge have many cases, multiple cases. Here, for example, we have 4, 25% each of them. And for each such belief, we perform the calculations to calculate the optimal decision, optimal action, and to calculate how good it is, to compare it with other optimal actions, so that we can bet the best optimal value or expected value of a payoff function. Let me find something with very complex. 5. Here are 5 in this belief. So as I showed you in this case, when the vampire is in Warszawa, we know for sure, and we just don't know about Pregor, whether he's alive or not. We may have different beliefs, and in the pre-calculated knowledge, we calculate for all possible beliefs the optimal action and the expected value of the payoff function, and we then use this table. In a way, it's a table for visible state and belief. So what you can see and what you believe in, to make a decision, of our artificial intelligence algorithm, what to do next. Okay, maybe I will try to find on visible state no, but I will show you now how this specification works with Svarog. Svarog, Dorban. So without this Dorban program, we just have Svarog specification, and we run it like that. We loop with the depth 4. So this is the height of the game tree, and we have information whether Dorban has wonified. So we can select none. Where is Dorban? Let's say place Krakow. Can Dorban see Pregor? Also false. Can Dorban see Pregor is alive? False. No, actually none. It should be none. Can Dorban see vampire? Let's say true. So the vampire is also in Krakow. And is Pregor following Dorban? False. Obviously, because if he had followed us, we would have seen him. And we don't. We don't see him. Okay. We press enter, and now we have a beautiful belief with 12%, 12.5% probability for each of the 8 cases. And the cases are, we know for sure that vampire is in Krakow because we can see him. So in every of the 8 cases we have placed Krakow for this variable. And for the Pregor, one of the 4 remaining cities: Warszawa, Wrocław, Gdansk, Poznan. Here. And we don't know, we have no clue whether Pregor is alive or not. So false, true, false, true, false, true. This is something that the program Dorban does for you, so you don't have to type all the input variable values. So let's now pretend that Pregor is in Warszawa, but he's dead. So we didn't want to fight. The decision was to go to Warszawa. So Warszawa. Where is Dorban? And can Dorban see Pregor? Let's say true. Can Dorban see Pregor is alive? Let's say false. So we can see that Dorban is dead. And can Dorban see Vampire? No, because Vampire did not move. He's still in Krakow. Is Pregor following Dorban? False. Now what will happen? What do you think? I think that because Pregor is dead, he will stop looking for him and he will just come back to Krakow to attack the Vampire on his own. Let's see. Yes, go to Krakow. We know for sure that the Vampire is in Krakow. He may have moved somewhere, so then we would be surprised not seeing him. And this actually happens sometimes. But we know for sure that Pregor is in Warszawa, and we know for sure that Pregor is not alive. So we just go to Krakow. None. What would be the input now? Krakow. We don't see Pregor. Don't see him being alive. Can Dorban see Vampire? True, because the Vampire is in Krakow. And is Pregor following me? No, he's not. Now attack Vampire. So, this is a very simple example. The situation was so that we had Vampire in Krakow and Pregor dead in Warszawa. So we first went to Warszawa. We happened to choose Warszawa as the first place to go. And we checked that Pregor is not alive. We saw it ourselves. Then we come back immediately because we know there is not anybody else who could help us, and the only person who could have helped us is dead, and that's why we just come back to Krakow and we attack Vampire on our own. And now let's give him something that is nonsense. Attack Vampire, and we say false, so we failed. But we are in Warszawa. Somehow it teleported us to Warszawa, and somehow we don't see Pregor, we don't see him alive, and we don't see Vampire, and Pregor is not following us. So this is nonsense, because after attacking Vampire we don't expect us to be teleported to Warszawa. Yes, we have a runtime error. Failed to interpret the result. And this is something that I call surprise. If you do it with Dorban, it is handled a little more smoothly. Not like that, like in Svarog directly. And in order to have this this handling, it is written also in the Triglav 000 document. You have to just override certain virtual function. This is information for C++ programmers that intend to use Svarog in their own projects. But it's just an experimental language, so please forgive me that this is possible. Just a runtime error thrown to the command line. Okay, that's all. So when we run this, and we just enter empty input, it will complain about illegal value. When we run Svarog with specification and we just type na n and type tab, he knows that the possibility is none. One possibility is none, or false, or true for the first input variable. Then another input variable is where is Dorban, so we can use p and tab place. So you see that the autocompletion works. This is achieved by the ncurses library integrated with the within Svarog. So here I would say, for example, Gdansk. Can Dorban see Pregor? True. And he's alive. We don't know where we don't see the vampire, so we don't know where the vampire is, and Pregor is not following us. Now we know that Pregor is in Gdansk. It's somewhat opposite to the former situation, but we don't have any idea where vampire can be. We just know that he can be in Warszawa, Krakow, Wroclaw, Poznan, not in Gdansk because we don't see him. And we know for sure that Pregor is alive. So 25% for each of these possibilities. Actually, they are reduced to various options where the vampire can be. And the first action is to ask Pregor to follow Dorban. So no matter where the vampire is, we know that it is beneficial for us to ask first Pregor to follow us, so that when we find the vampire, hopefully we'll be able to find him soon, so maybe in Warszawa. Let's answer that we are still in Gdansk and now the Pregor is following us. So we have none plus Gdansk, true, true, false, true. And the next decision will be, of course, go to Warszawa, because this is the only city connected with Gdansk in this game where we can move. Yes, go to Warszawa. And we still don't know whether the vampire is here. But we can say that we are in Warszawa, we see Pregor is alive, we don't see the vampire, and the Pregor is following us. So we will go somewhere else, either to Krakow or to Poznan. I think Krakow is the option now. Yes, and the belief contains only three possible cases. Before we achieve Krakow, we know that the vampire must be in Krakow, or Wroclaw, or Poznan, and 33% for each of the possibilities. And we know that Pregor is in Warszawa with us, because he's following us, and we can see him. Now go to Krakow. Let's say that we have seen the vampire there. So this will change. True. We can see the vampire, and we can see also Pregor because he is following us. So he must have gone with us. Not necessarily true. We just would be surprised if we don't see him. And now we are in Krakow. Attack vampire. Yes, that's exactly what Dorban is going to do, because he knows that he has support of Pregor, and he is going to attack vampire, and he will expect 85% chance of winning the fight. So let's make him pleasure and say true. We won. We still see the vampire. Everyone is present and alive and true. Attack vampire all the time until we give illegal value and the program is stopped running. Okay, thank you very much. I think I have shown you the most important features of Dorban and Svarog. I showed you how to use Svarog from command line, and it's much more fun to use it in the Dorban program, GTK-MM. But you need to compile it first, and it is a little more problematic maybe. But you can use Svarog directly. And maybe in the next video I'll show you how I produce the pre-calculated knowledge. Okay, see you then.